2014 A3. So the 3D graphic below shows a tangine, which is a type of clay oven frequently used in North African cooking. The drawing on the right shows the incomplete elevation of the tangine. The upper lid is based on two semi-parabolas, which are inscribed in rectangles, and the lower dish is based on a semi-ellipse. Part A. V1 and V2 are the vertices of the semi-parabolas. P is a point on the semi-ellipse. Small portions of two of the curves have already been drawn. Complete the elevation of the tangine, showing clearly how the exact length of the base is obtained. Now I'm just going to quickly go over one of the parabolas here at the top. You can just use axial symmetry to get the second parabola. So what I'm going to do is just take the width there that they've already given us, and I'm just going to step that off along the side like so, and I'm going to lightly bring those across there, and likewise then I'm just going to measure that distance there at the bottom, and I'm going to step that off along the bottom, and I'm going to join that then to V2. Like so. And then all you need to do is draw in your parabola there like that. And then you can just mirror your 1, 2, 3, 4 points using axial symmetry straight across the top of the page there. That's all straightforward enough, so I'll let you do it by yourselves. Next step then, down at the bottom here we have our major and minor circles. We have our major axis, minor axis, and they've already given us a point P on the ellipse. That's actually a, let's say look at about a 20-degree line. So what I'm going to do, like you would be familiar with from junior cert, is divide it up 60-30. And I'll show you in a moment then how to find the exact length that they're mentioning there in bold writing here. But all of that there. And what I'm actually going to do there as well is bring point P straight across. And I'm just going to use axial symmetry there. Just make it slightly more accurate when I'm drawing the curve. I'm just going to mirror point P across. And then, as you should be familiar with, where it hits the major circle there, we're going straight up. And from the minor circle, straight across. And that will give you there a series. You can see where that matches up perfectly with the actual portion of the ellipse that they have drawn there. Like so. So that will give you your points if you were drawing the semi-ellipse. Now we don't need to draw the full thing, however, because we can see this base is going to go horizontally out across there. Now, show clearly how the exact length of the base is obtained. What I want to show you here, if you notice, this point is on a horizontal line. So if you imagine if that base was down slightly further here, and it lined up with those 60-degree lines where they hit the minor circle, right? If I had the base there right where my pencil is, you would notice that these 2 points would be on the base if it was slightly lower. And you will also notice that those points were located by this horizontal line where it hits the minor circle. There's a line going back from the center to the major and straight up. So what I'm going to do is I'm going to try to recreate this horizontal line, only I want it to line up with this bold line where the base actually is. So, bear with me now for a moment. I am just going to extend my base out slightly like that. Right, so there's my base. I know it's somewhere along this line. I don't know how long it is yet. Just yet. Where that base intersects the minor circle, 2 points, I'm going to join that point back to the centre of the ellipse, and I'm going to extend it out both sides. Now I'm just going to highlight one of these in a slightly different colour. Okay, so I've extended my base, join to the centre, extend out, and from here I'm going to go straight up. And that would be how I would locate a point on the ellipse. Okay, so if you think there's your line that we would normally radiate out from the centre, across from the minor, up from the major, that gives us a point. This point just happens to line perfectly up with the base. And similarly over here, there's a second point on the base. Now what you could do then, make sure it's nice and accurate, is just slightly extend your ellipse past the base. Just lightly, and then you can come and darken it in. There we are. Last bit then, draw a tangent to the curve at the point P. So this is going back to junior cert for how we would draw a tangent. So the first thing we're going to do is locate our focal points. So to get our focal points, we take half the major axis and we swing it from the end of the minor axis. And I'm just going to label that there as well, F1, F2. Next step then, join point P to each focal point. We bisect the angle. And that there would give us our normal, and as we all know, our tangent is perpendicular to the normal. So that there then is our tangent.